Hey, everybody. Welcome to this Knowledge Shared series. I am Charlie Matthews, the founder and CEO of Empowering Brands. And today we are talking about sustainability. And I have some amazing guests that I'm just really excited to learn from and just, spend time with you today. So I'm going to start, just let y'all have the floor and introduce yourselves. Sarah, I'll start with you.
Perfect. Yeah. So I'm Sarah Stewart. Obviously, I work at Southwest Research and Institute within the Fluids Engineering Department. My background is in chemical engineering. I have my bachelor's in chemical engineering. The interesting thing about Southwest is that it allows you to grow and move. So I actually started my time at Southwest doing catalyst and after treatment research and development for emissions reduction. And now I've kind of switched and I'm doing more, novel desalination techniques and some advanced carbon sequestration techniques within the fluids engineering department.
Yeah, and I'm really excited to learn about that. So definitely dive into that in a minute. Jackie, you want to go next?
Sure. Well, hey, everyone. My name is Jackie Manders, and I am also an engineer in the Fluids Engineering Department. I've been at SwRI for just about 9 years now. Time really flies. I have a mechanical engineering background and graduated from Texas A&M University. Whoop. And most of my work so far has been in flow component qualification work. So traditionally, we're tied more specifically to oil and gas industry and qualifying components for that, whether it's integrity testing or flow performance testing. But recently, my focus has switched gears to hydrogen related research. And so I think we're going to talk a bit more about that today.
For sure. And there's so much there. And I have to, all my Aggies are celebrating with you right now. Anytime we're in Texas, I'm from Alabama and an Alabama fan, but I have to go for the Aggies because of so much of industry lives right there. So Nicole, go ahead and introduce yourself to the group.
Hey everybody, my name is Nicole Lemon. Last name's more fun than my first name, but I'm in the same group as Sarah and Jackie at the Fluids Engineering Department. I graduated from Baylor, so sick and bears if we're going to be doing that.
I love it.
I've been here at Southwest Research Institute for 2 years. Before that, I came from a purely mechanical design background in the aerospace industry. Since I've been here, I've been doing some mechanical design work as well as I've been doing a lot of work with our safety valve program, managing that program for downhole equipment. And we're looking at more recently into how we can test existing components for use in carbon sequestration and injection.
I mean, wow. I mean, I hope that this is not brand new for everybody, but a lot of this is new information. And I think that this conversation is going to be really great for our industry because we need to understand kind of where we're going. And so when we think about this, I know we kind of talked about this on the sustainability front, let's talk through clean energy, clean water, and climate action. And I, love that word action, right? To make sure that we cover what we can do for our industry. And because I know there's a lot of questions, especially around the hydrogen space. I've heard a lot about that. So if we can start there and just kind of dive in. Jackie, do you want to take the reins?
Definitely. So thanks, Charlie. Yeah, there's a big push towards hydrogen, and the focus there is really clean energy and reducing carbon emissions. We don't want to continue to contribute to global warming, and so coming up with different types of alternative energy sources is really important. And hydrogen is something that has a lot of potential because of its ability to store energy. So, we have these solar energy sources and wind energy sources that are convenient, but being able to store it for times when you need it to come in is a bit more challenging. And so that's a lot of where the big push towards hydrogen is coming from. The thing about hydrogen, of course, is it is incredibly dangerous. It has a very high flammability range mixture in air. So like when you compare methane, for example, with hydrogen, you're looking at a 4 times wider LEL concentration to air ratio where it could be flammable. So basically that means is whenever you're working with it or testing it, you have to be very, very careful. There's a lot of safety hazards that are associated with it. And so making sure that whatever products and components are going to be used to contain hydrogen are reliable and that they can, handle the test and go through all the different conditions it's going to see is really important. And that's a lot of the work that I've done so far is tied into actually exposing these parts to high pressure hydrogen at extreme temperatures and repeating that multiple times and seeing that they can hold up, they're not going to leak and lead to any kind of a safety incident.
Yeah, so I'm just quite bold. Just this industry in general, right, is bold. But just thinking through that, making sure that there are safety protocols even for testing the next level, right? How some really wise minds out there to come up with that and make sure that we're on the right track. So I guess what else is there in that space when you're talking about carbon capture? What else do we need to be looking at? Sarah,
Yeah, I can go over the overview, and then I think Nicole can speak on the specifics of the testing. So you hear carbon capture, and it's this big scary word because we know we have, you know, so much carbon in the air already. You can focus on, capturing what is being put out right now. You can focus on ending emissions, which is what I used to do, is how do we capture it in the streams. But something that we're really good at is doing downhole flow component testing. So it's more so the question is, how can we take the equipment that we already have, the equipment that is used in oil and natural gas, and use it?
When we think about what can we do to make equipment more efficient to capture emissions. So a lot of the things that we talked about were fugitive emissions, that is things that we can control, right? We know that this is going to go pass through the actual equipment, and we can either, flare it or we can capture it. So that's the kind of knowledge that I have. So can you tell me a little bit more about kind of how you help people in that realm of carbon capture?
Yeah, so we see a lot of, just like hydrogen, we see a lot of people looking into how to store CO2 and how to sequester it in terms of like keeping our environment cleaner. I haven't worked very much on the fugitive emission sides per se, but what we've been doing a lot of is the lab that I work in does testing on subsurface safety valves, which during normal production of wells is kind of the last line of defense that keeps the fluid in the well when you don't want it coming out of the well. And that's what it's designed to do. So what we're looking at right now is there any qualification of those valves that can be done for holding CO2 in a well? If we specifically designed a well or a reservoir to hold CO2 to sequester it, is existing equipment capable of doing that? There's a lot of different factors that make CO2 more challenging. The fact that its curve with the supercritical options and all those things, and the changing of pressures and temperatures make it more complicated. It can get very cold when it goes through any sort of restriction due to Joule-Thomson cooling. And that means that any component that you are using to restrain it needs to be able to withstand those very cold temperatures as well as the density changes. So we've been looking at qualifying our testing systems and adjusting our testing systems to be able to qualify these existing equipments and potentially new designs to see if they would be rated to hold CO2 or meter the flow of CO2 for either injecting carbon into a reservoir to hold it there, or keeping carbon in a reservoir as opposed to letting it come back up. So that's an area that we've been really trying to develop at our facility. There's also different groups here that are looking at the other factors of carbon sequestration, including the pipeline that transports the carbon to where the CO2 where you need it to go, and also transporting it in trucks and things like that. There's a lot of complications that existing technology has been designed to do similar things, but with CO2, it all needs to be rethought.
Okay, and that's really what y'all are doing. You are working with manufacturers or the end users to say, okay, this is the equipment that you have. Can it be used for this? And to what extent does it need to be changed? And really providing those challenging solutions is what it sounds like. Okay, let's this is the future. This is the way that we want to go. What are the steps that we need to do? Is that fair?
Yes, that's the primary goal.
Okay, wonderful. Okay, let's shift gears a little bit to clean water. Y'all know I have quite a passion for water and making sure that we have access to clean water. But what does Southwest Institute really, how are y'all jumping in and helping with that?
Right. I can take over this one. So as I'm sure you're well aware of, 750 million people globally lack access to clean water. So what we did is we got together and had a conversation and said, what can we do to help solve this problem? And the answer was, we are fluids people. We are familiar with pumps, piping. We're very familiar with doing things at high pressure, high temperature. How can we apply these skills? And the answer to that was really investigating desalination methods and then trying to apply it to the fields that we're already in. So oil and natural gas is kind of one of our strong fields that we're comfortable in. So we're investigating, how do we actually use the produced water from production to kind of change that and do a modular system that you can take out into the field and desalinate that and provide clean water in a source that maybe wasn't traditionally used. So we're kind of using the skills that we have and the team that we have to grow upon that. And I would say, compared to, kind of what Jackie and Nicole are doing, this is a little bit newer in the research. So when you're looking at the technology readiness level, this might be a little bit newer than we've done before, but we're very familiar with research. So we are not scared on taking on a new problem and looking at it and trying to figure out what the best way is. And some of the more specific things that we're looking at is, alternative methods, like traditionally use reverse osmosis. We're doing investigations on if there's another method of desalination that could be used more modular. How do we incorporate this with clean energy? How can you use solar energy or something more renewable to energize these desalination plants? So that's something that we've been looking into, and we're trying to work with oil and gas for remote water treatment, as well as some local municipalities where we can help them solve some of their problems, make it more energy efficient, and provide clean water to a wider area of people.
Yeah, I love that. I love all the different ways that we can reuse the water. Every single industry can do better with how we use our water. And so I think it's wonderful to have research being done to see, okay, can we do it better? Is there a better way? Because that's what we need. We need, and we all know this from just looking at the different ways the environment is showing us that we need to conserve our water and really pay attention to it. It's very strong, and see, okay, what can we do as a community, as an industry, to change the way we use water? So that's wonderful to hear. As far as kind of that climate action, I do see water as being part of that, but what other elements are y'all working on?
Well, I think I can jump back in talking a little bit more about, again, hydrogen as something that's going to drive us forward. So something that we have a lot of experience with is doing pipeline leak detection research. And if you think about, if we're going to incorporate hydrogen as a reliable energy source in our country, how are we going to distribute it? And so one of the ways that we've thought about doing that is mixing it into the existing pipelines. The problem there is then you have some, chemical compatibility issues. You're looking at hydrogen embrittlement, and you come to the question of how much hydrogen can we mix into natural gas to make it where it's going to damage the pipeline itself. And then also, if it's leaking, how are we going to detect that? So we've done a lot of research recently on our traditional leak detection techniques and what happens if we mix in hydrogen at different concentrations. Are we able to detect it still? Does there need to be new technology developed to be able to find a leak? And in that case, we're not as concerned about hydrogen leaking. I mean, from a safety standpoint, we are, but it's not going to contribute to the emissions. But if you're mixing it with natural gas, you have to be concerned about, could this hydrogen mask the natural gas that is leaking and the emissions that is now creating? So there's just a whole bunch of different aspects to it that once you really sit down and think about it, things that have to be figured out before it can become, in practice in our country.
Right. And it's really nice to have y'all as like an institute that you can go to ask these questions. So I know a lot in our industry, that in the pump industry specifically, are like, okay, how is this going to change things? What is the process going to look like? How can we use what we have and also participate in this new change of sustainability? And so I love it. I love that y'all are, out there and that people can use it as a resource. If there is someone out there that is saying, okay, I love this, I want to work with you, what does that look like? How does that process normally work? Nicole?
I can take this one. So there's several options. One, we can provide our contact information, and the nice thing about Southwest Research Institute is it's a very collaborative environment across, like, all of me, Sarah, and Jackie all focus on slightly different things, but we all work right next to each other. So it's very easy for us to communicate. But also our division is large and the Institute is large. So there's someone with the expertise that you're looking for here, and we all know how to find them. We have an internal system where we can connect you with the right person. So even if I'm not the right person, or Jackie's not the right person, or Sarah's not the right person, we can find who that right person is. And a lot of how it looks is we'll have some initial meetings to really try to get a sense of, like, what your goals, problems, needs are, to connect you with the right person at Southwest Research Institute that can help work towards those, and essentially establish what type of areas we're needing to move into. If it's purely research, if it's analysis, if it's testing, and we work together to define that scope of work. And then we can move forward with proposal, whether that be for testing, whether that be for computational analysis. Different types of problems are solved different ways, but we pride ourselves in being able to bring multiple disciplines together to solve complex problems based on the range of knowledge that we have and how we work together.
I love it. So I'm going to let y'all kind of all have a moment to kind of give us one last little nugget on sustainability from your perspective, and just kind of what our listeners need to know about it. I'll let y'all decide who goes first.
Right. I can start out. So something that I've learned just in my, few years of working at Southwest Research Institute is you look at these huge problems and they're very, very scary. But once you start breaking them down, you realize I have the tools to solve these problems. So that's something that, we can help people do. Our motto here at Southwest Research Institute is deep sea to deep space, which almost sounds like an exaggeration, but it really isn't. We do work on projects all the way from the deep sea, working on submarines or undersea pipelines, all the way up to, Mars missions, or, signaling and analysis of really deep space things. So it seems scary, and that's okay, but we can usually create a team that can kind of chip down at the problem until we can find a solution that works for you.
Love it. Either one of you want to add anything else on sustainability for our listeners?
Well, I would say that, Sarah wrapping up SwRI as a whole is a really good interpretation of what we do, from deep sea to deep space. And our mission statement is benefiting the government, industry, and the public through innovative science and technology. So really the innovative part there is something I think we focus on. We like the challenging things. We like to look at problems that are hard to solve. And moving towards sustainable energy, I mean, this is a very big, challenging problem. And so being able to break it down and to have the expertise that we need to solve these problems is really something that I think we can bring forward. I mean, hydrogen specifically, for example, there was so much work being done at SwRI on hydrogen, and we really weren't aware of it until like a couple of years ago. And we said, hey, let's get everyone in the same room and talk about all the stuff that we've been doing with hydrogen. And we realized there had been a lot of research with engine testing and emissions testing and hydrogen embrittlement testing. And so once we put it all together, we realized we do have a lot of expertise that we can offer this industry. And so I think that, whatever the problem is that comes our way, we have a lot of different folks that can work together to try to help solve it and move the technology along.
I love it.
Yeah, I think Sarah and Jackie touched on the main points. I really liked what Jackie said in terms of just getting everybody in the same room. I think that's something that we all can learn from, is getting everybody in the same room. Everyone has slightly different backgrounds from their own personal perspectives, slightly different knowledge sets, slightly different skills. And when you get everyone in the same room, that's how you're able to tackle these big problems, by leveraging all the specific knowledge sets, specific perspectives. And that's how we're going to move forward, is different groups within industry, different groups within manufacturing, and different researchers all getting in the same room and talking about what knowledge they have and sharing that knowledge so that we can make real progress in the sustainability area.
Yes, and y'all know I love collaboration and bringing people together. So thank you for having that same common mission. I will definitely put all of your information and how people can get in touch with you in the notes. And I just am so thankful that y'all spent time with me. And I feel like I've learned a lot and really kind of know that I guess I have a piece that we also have some answers out there if we put our minds together and really talk about what challenges we do have, that there are some answers out there and definitely a great team to work with. So thank you so much for your time. And I look forward to talking with y'all again for sure.
Thank you so much.
Thanks